Hello everyone, this is Humeraban from third year CEC. So I'm recording this video as a part of my second assignment from the course Introduction to Quantum Technologies and Applications. So the topic I have got here to discuss is about quantum internet. Let us see what all the contents that my PPT contains. So first starting with the limits of classical internet, introduction, concepts, QKD, which is quantum key distribution, building blocks and how it works, applications, some advantages and its challenges, research and finally conclusion. Without directly stepping into the quantum internet, let me first tell you what are the limits of the classical internet. Starting with uh, what does our internet is? Internet is basically a interconnected large system which consists of multiple number of computer networks. Here, these internet is used for transferring information or for sharing resource purpose. So here are some of the uh, challenges that classical internet has. In the current existing classical internet, it's very vulnerable to hacking and data theft. Like we can easily hack. We can see so many cybercrimes has been going on with this classical internet. Limited encryption security. So it's somewhat very difficult to provide the entire security in the existing classical internet. A signal loss over long distances. It might be due to some disturbances. There's a chance of losing signals when the nodes, which means the sender and receivers are having a long distance between them. It mostly relies on unpredictable randomness and it's inefficient for quantum level computing. Like if you are going to use quantum computers or anything related to the quantum physics, applying the classical concept is somewhat inefficient for the outputs to get properly and very clearly. So this is all the limitations of a classical internet, which inspired the scientists to come through the quantum internet using the quantum mechanics. So starting with the introduction, quantum internet is nothing but a next generation communication network that transmits information using quantum signals, which are nothing but qubits. Here, qubit is just like a bit, but here qubit can be 0 and 1 or both. But as compared to the classical bit, which can be either 0 or 1, this qubits relies on the quantum mechanics. Mostly there are four fundamental principles in the quantum physics. Those are superposition, entanglement, uncertainty principle, and wave particle duality. So, on the basis of these four principles, quantum internet uses superposition and entanglement most to ensure the secure and high-speed efficient data communication. So, its main goal is to provide security and make the process very faster when compared to classical internet. So, it all is done by using quantum computers, sensors, and devices across the globe for the secure and powerful computation and communication. Let's go through the concepts of quantum internet. It involves the concepts like qubit, superposition, entanglement, and teleportation. Qubit is a fundamental unit of quantum information. It can be a 0 and 1 at once, or maybe a superposition of both. Unlike in classical bit, it can be only 0 or 1. The next concept is superposition. Superposition says that quantum system can be exist in multiple states at a same time. But to get the definite state, it has to be measured. After measuring, it results in a form of some classical outcome. So this is all about superposition. Then moving to entanglement. Entanglement is a phenomenon that says that when two or more particles are correlated to each other, when the changes in the one particle directly influences the changes of the other, no matter how far apart they are, maybe miles apart. So this is all about entanglement. It says that instant link between two particles. Teleportation is transferring of quantum states, which means that the particle itself is not sent. It is destroyed at the receiver's sender's side and recreated at the receiver's side. So these are the different concepts which are embedded in the quantum internet to make it faster and secure. Yes, QKD is quantum key distribution. It is one of the applications of quantum internet. Quantum key distribution is a method of sharing or creating a secret encryption key between two users, the sender and the receiver. It creates an encryption key which is known by the two users to for the process of cryptography. Like if a sender is sending one message, at the sender's side, it gets encrypted, which means it gets locked. That plain text is converted into ciphertext so that the transmission medium through the transmission medium the actual content of the sender couldn't be leaked or couldn't be uh, known by the hacker or the third party. At the side of a receiver, with the same key it has to be decrypted, which means with the same key we have to convert the ciphertext into the plain text so that the important plain text, which means the important text which has sent by the sender has to be received by the receiver very securely without any third party involvement or without letting them know about what's the actual content present in them. So this is all about QKD. Here there are two different protocols involved in QKD. BB84 was the first protocol which was made in 1984, which says that here a sender sends a sequence of strings with some bases like the plus base and cross base, which is rectilinear and diagonal. At the sender will send the qubits with the if the sender uses the plus basis which is rectilinear, he has to send that send that bit using some angle like 0 degrees or 90 degrees. In this way the receiver receives the photons, and at that time this receiver has to guess what basis did the sender has applied on this particular input. While detecting or while predicting the base of the current input, the same type of base also can be detected by the hacker or the third party person, which is Eve. So before letting the receiver know about what's the actual input or the actual key that the sender has sent him, before him the hacker may also know. This is the advantage from BB84 protocol, which was later developed or which was later overcame by this protocol, which is known as E91, which mostly uses entanglement. Entanglement is nothing but when two particles are correlated, the changes made on the one particle directly reflect onto the second part. So on using this entanglement phenomenon, this E91 protocol has been introduced under the quantum key distribution. Let's see what's the architecture of this quantum internet. Architecture which all tells about what are the components used in this quantum internet. Let's start with the quantum nodes. Nodes might be quantum computers, anything related to these quantum things, which stores and process qubits. And moving to the next one, which is quantum channels, used as a medium to share their signals. Here in quantum internet, satellites are also being used as this quantum channel. So in this example, in the image I have provided, we can see that the satellite has been used as a quantum channel in sharing their data through which is acts as a main signals, and the quantum repeaters, which are used for maintaining entanglement, which is very necessary part. Here maintaining the entanglement is very necessary, so quantum repeaters are used as a part of this. And quantum memory to store all the data which needs some storage devices. For that purpose quantum memory is used. Classical control layer, it is used for syncing and error management and all. The final one is network manager, which monitor all the network connections and how all the data gonna shared and how all the keys or sharing between sender and receiver. These all things are being detected or monitored by the network manager. So this is all about the blocks involved in quantum internet. Quickly moving to how does this internet works. First of all, it creates an entangled photons and then distributes those photons at both sides, which is at sender and at receiver side. After that, through the communication channel, they'll pass the qubits or the photons. And using these quantum repeaters, they maintain the entanglement state, which is when there's a change at the sender side, it's automatically reflected at the receiver side too. So that's why providing quantum repeaters is a main part of this quantum internet. Then, not only this, apart from the quantum channel, classical channel has also been used in this quantum internet, which works alongside to coordinate all the transmissions and some error connections. Like I have talked about the BB84 protocol. In that protocol, they'll use both quantum and this classical channel, where the quantum channel is used only for sharing the qubits, whereas this classical channel is used to transfer the communication, just communication only about the basis and all, where actual bit value has not been revealed or not been uh, shared between those two users. So in this quantum internet, classical channel is also get supported, which supports quantum in all the uh, normal conversation between two users. And finally, teleportation, transferring of those data is done through this all these things, all the steps, that's photon, qubits, repeaters, and those two different channels, which are quantum and classical channel. So this is all about how the quantum internet works. Next, moving to the applications. Here, ultra secure communication. From the first onwards, I'm telling that this quantum internet is very useful in our future also. Like everything will be shifted to faster and secure one. So quantum internet well works here. With that, it's one of the major application of this quantum internet. Distributed quantum computing. Like to reduce the load on the single one, this distributed phenomenon well works there. And to solve the complex problems, distributed computing is very useful. And quantum cloud services, we can provide all the services in cloud so that it's very easy to access. Quantum sensor networks, and finally scientific research. Scientific research has been going on this quantum thing, quantum physics related things. It might be about quantum computers, about the communication, or anything related to this quantum has been still in a process of research, so that we can be able to search for many new things related to this quantum mechanics. So quickly moves to the advantages and challenges what it has. It's unbreakable data security. It provides very secure and faster communication, high-speed transmission, reliable long-distance communication. It is only possible using entanglement, works with quantum computers, as it's all about maintaining the nodes which are related to quantum. So it well works with quantum computers, and it serves as a future-proof technology. And the challenges which it has are quantum states easily disturbed. Like if any of the particles are have been in coherence with the changes in environment, they quickly get decoherence. So it is considered as a challenge. Some short communication range, high setup, which is very expensive to maintain all the infrastructure of these quantum related things, complex error correction, and no global standards yet. So these are about advantages and challenges in quantum internet. So let's see what are the current research and developments in this quantum. China was one first introduced its Messieurs satellite. in 2017, which was the first satellite which used as a channel for quantum communication. Like in the components, I told about quantum channels, which also use satellites. So this is the application or the development done by China in 2017. And European Quantum Internet Alliance, some famous companies like Google, IBM, and MIT have been working on these quantum computers and quantum technologies. They are uh, saying that quantum computers have been already prepared by us. So they have working on the project of this quantum internet and all. So India's quantum mission, which is a national mission, which was launched in 2023, which its main goal is to make India to stand as a leader in quantum technologies and learn from the different countries what all these they are doing. So to conclude that quantum internet is a revolutionary leap beyond classical communication. It all includes the fundamental basic quantum mechanic principles like superposition and entanglement, and also quantum key distribution, which promises ultra secure and high performance networking. Though these challenges remain in scalability and implementation, rapid advancements in research shows that the future internet will be quantum powered. So everything will be for these types of generations. We are well searching for the fastest and very secure things. And also by seeing the limitations what the classical internet has, we all prefer to have this type of security which quantum internet provides. So it's having a scope that in future quantum powered communication may exist, and maybe existing because of its application, because of its advantages. So connecting not just computers with the laws of physics themselves. So this was all about quantum internet. So thank you for listening.